our definition for negative infinity, it has the same setup, but here our function is less than a very large negative number called n. So here's the example, and let's start our preliminary analysis. So we're going to start with x minus a, x minus 3 in absolute value. Then we're going to look at the function is less than n, so we're going to take our function is less than n, and we're going to manipulate this until we get back to absolute value x minus 3. All right, the first thing I'm going to do is do the reciprocal of both sides, so that'll be x minus 3 squared over negative 1 and 1 over n, and we're going to need to switch the sign. And if you want an explanation on why the sign flips, see the example before this one. Now we're going to, I'm going to get rid of my negative 1 by multiplying it to the other side. When you are working with inequalities and you multiply or divide by a negative, you have to flip the sign again. And remember, I want x minus 3 in absolute value. So now I'm going to take the square root of both sides, which does not change your inequality. And I want to make sure that this inside was positive, because it was for sure positive when it was squared, and now that the square is gone, I want to make sure it's positive, so put absolute value on it. And so this is my step 3, that's my delta. All right, now we're ready for the proof. Okay, so given, and this is different, n is a negative number, so we're going to say given n is less than 0, choose delta to equal the square root of negative 1 over n. Now remember, delta needs to be greater than 0, and it is, because this is a negative, and a negative divided by a negative is a positive. Now we're going to start with our if statement. If then, and we're going to work from our if statement. So we have, if x minus 3 is less than delta, then we could do reciprocal of that. So I'd get there. Oh, but if I do reciprocal, I got to change the sign. So greater than. I then could square both sides. If you square this, it's going to be positive, so I don't need absolute value. And if you square a 1, you get 1, so that's why you're not seeing it on top. Square 1, you get 1. Square the delta, you get delta squared. Then I want that negative, because I'm trying to get to my function. I want to multiply both sides by a negative. But when you do that, your sign flips. Okay, so I got here. Now that I have my original function, I'm going to go ahead and plug in my delta that I chose. So this equals negative 1 over this new delta. And when you square the square root, it goes away. And then if you multiply by the reciprocal, you get n. So we have shown that the function right here is less than n, which was the conclusion of the theorem. Therefore, we can conclude by the definition that the limit as x approaches 3 of negative 1 over x minus 3 squared is negative infinity.